Hi guys, this is Miss Scott here. So here is your bad joke of the day. What do you call a bull that likes to sleep? A bulldozer. Alright, it's pretty good. Okay, so today we are going to learn how to find arc measures. So in order to understand arc measures, you need to know, first of all, what a central angle is. And a central angle is if you go from the center to the outside. This right here would be a central angle. So say this is 50 degrees. This central angle would be 50 degrees. Okay, now a minor arc is an arc that is less than 180 degrees. So it turns out that this arc right here would be the same as that central angle. So this would be 50 degrees, the arc measure, and that would be an example of a minor arc. Now a major arc is an arc that is over 180 degrees. So if I would go around this way on this circle, well, we know what the entire circle is 360 degrees, so this arc would be 310 degrees. So that is an example of a major arc. A semicircle is, as you can probably guess from the name, half of a circle. So that would be a 180 degree arc. So this right here we would call a semicircle. Right? And it always has a measure of 180 degrees. Adjacent arcs are arcs that are side by side. So, for example, this 50 degree and the 310 degree that we talked about a moment ago, those would be adjacent arcs. And then the arc measure is pretty much the same thing. So like 50 degrees is the measure of this blue arc. So it's just a number. This is pretty self-explanatory, but congruent circles are circles that have the same radii. So if you have two circles that have a radius of 5 inches, those would be congruent. Same with congruent arcs. Those are actually arcs with congruent measures. So if you have two arcs with 50 degrees, those would be congruent. Okay, so our first kind of main idea of this lesson is that the measure of an arc is simply the measure of its central angle. And we mentioned this earlier, but the measure of a semicircle is always 180 degrees. Okay, and we're going to use those two ideas in the next few examples below. So here it says, use circle P at the right to sketch the following items. So I need to make an arc AB that has a measure of 70 degrees. So I'm going to do my best to kind of just sketch this. Let's call this point A and this point B. And then this arc measure from A to B, we're saying is 70 degrees. All right, so that's the blue that I have here. And now I need, in step 2, to add a point C so that the measure of arc A to B to C is 200 degrees. So I'm going to try to make that a little bit bigger than a semicircle because 200 degrees is more than 180. So this arc from A, let's draw on this radii from P to C. This arc from A to B all the way over to C is 200 degrees. All right. And now the third thing I need to do is put a point D so that I have a semicircle named arc BAD. No, I guess it's a bad arc. All right, so from B through A to D, I'm going to make this dashed diameter here and call this point D. So now I have this semicircle BAD. All right. I actually already have diameter BD on the picture. That's that red dashed line from point B to point D. And radius PA is also already on here. That was the first thing that I drew. So this line from P to A would be a radius of PA. And then lastly, central angle APC. So if I make an angle from A to P to C, that would be this angle right here. And let's see, how many degrees would that be from A to P to C? Well, it looks like from A to B to C is 200 degrees. So this would have to be 160 degrees, so that we make 360. So there's central angle APC. Okay, so just a few quick really ideas in one circle. So I know there's a lot going on here, but I tried to color code it so you guys can differentiate between the 6 examples. All right, now our postulate 23 has to do with arc addition. And this is actually probably going to look really obvious once we start to discuss. It turns out that the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So for example, if we have this circle here, and here's the center of the circle, if I would look at this arc from A to B, all right, so we have this arc from A to B, and if I look at a second arc from B to, let's call this point C, you can simply, to find the measure of arc AC, so say I wanted to find the measure of arc ABC, I can find that by just adding the measure of arc AB and the measure of arc BC. So it's okay to do that if those arcs are next to each other. You can just add them together to get the whole arc length, or arc measure. All right, so we're going to use that idea in a few examples here. In example 7, it says to find the measure of arc ST. ST is from here to here. And now what I notice is that PR is a diameter. So arc PR going this way has to be 180 degrees. So to find just from T to S, I can take 180 degrees minus those other 2 arc measures, 64 and 42, and that's going to leave me with 74 degrees for arc ST. All right, so now we know this is 74 degrees right here, and we can find the measure of arc QTR. So let's grab another color here. Say I start at Q, and then I go through point T, and then I end at R. That's going to be a major arc, I notice, because it's more than 180. So how I see this is that I have these vertical angles here and here, meaning this has to be 42 degrees as well. So I can simply just add those 4 angles together. So if I add the 42 degrees in the top, and then the 64 degrees, and the 74 degrees that I found in part 7, and that last 42 degree angle, that's going to be the entire arc measure, which is 222 degrees. So we thought it was a major arc, we were right. All right, so let's look at example 9. We have the measure of arc RSP. So if I start at R, go through S, and then end at P, well, we can probably do this without any calculating. That is a semicircle. So that has to be 180 degrees. All right, and then lastly, let's find the measure of arc QRP. So starting at Q, going through R, and ending at P, which is almost the whole circle. So, well, the whole circle would be 360 degrees. And then I'm just taking out that 42-degree measure in the middle. So I will be left with 318 degrees for that arc measure. Okay. Couple of more examples on the back that's going to involve a little bit more algebra. All right, so we are asked to find the measure of arc BAD, so all the way through here. Well, in order to know that, I need to know what these two congruent arc measures are. So what I'm going to do is I'm going to call this X and this arc X as well. And then I know that from B to C, that's a right angle, so this has to be 90 degrees. So if we just focus on this half of the circle, my goal right now is to try to figure out what X is. Well, that highlighted portion, which contains X, 90 degrees, and then that other X, is a semicircle. So I know it has to add up to 180 degrees. So that means 90 plus 2x equals 180. If I subtract the 90 from both sides, I'm left with 2x equals 90, and then dividing by 2 gives me x has to be 45 degrees. So now to find my answer, to find that length of arc BAD, or the measure of arc BAD, so I have 45 degrees plus this semicircle from A to D is 180 degrees. So my final answer is going to be 225 degrees. Okay. One last idea in this lesson is to tell if arcs are the same measure, or the same length. So what they're asking is if we think from J to K is congruent to from R to Q. Well, if the question asks, are their measures the same, we would say yes, they're both 105 degrees. But it's asking if these arcs are congruent, and the only issue with that is that this first circle has a radius of 4. This one on the right has a radius of 4.5. So they're actually not congruent because the circles have different radii. And if that's the case, they can't have the same length arcs. So the circles have different radii, so they have different sized arcs. It would be true that they have the same measures, but they do not have the same sized arcs. And we're going to talk a little bit more about arc length later in chapter 10, but just to throw that idea out there, they have to have the same radius to have the same length. All right, so you are going to get some practice on these types of problems. Section 10.2 worksheet, and if you guys have any questions, please feel free to ask me at any time.